Hi, my name is John Baur. I'm a technical lead and senior developer slash Angular instructor here at Oasis Digital. And today I'm going to talk about Angular schematics. So I called this talk Removing the Guesswork with Angular Schematics. And I want to start off by talking a little bit, not about the how of schematics, but about why you would go about using schematics. I've been on a few projects in a row now where I've been tasked with starting up a new project, designing and implementing a new architecture for that project, and then carrying that on and making sure that all of the developers maintain this new or adhere to this new architecture and the new standards that I've set up. And it usually starts off great. It's me and a few other designers that are working closely with me on the team. We design exactly how we want the system to work. We start implementing features and rolling them out. And since it's this small team, it's really easy to make sure that everybody is doing the right thing and everybody was there for the initial design. So it's easy to keep us all on the same page there. But inevitably, sometime soon, either months or a year out, whenever, there's a shift in the project, and it changes from the small pet project, a proof of concept we've been designing, and now it's a real application. And so over the next months, we've got new developers coming on the team, maybe many at a time. We've got original developers rolling off the team. So people who were there for these initial decisions aren't there anymore. Maybe I'm not there anymore, and I've got to transition the whole project to somebody else. And so you're faced with this problem of, how do I make sure that my team keeps working with the standards that I put in place? Now, there are several facets to this answer. It's not schematics and that you're solved. But schematics can go a long way to helping solve this problem. I'm going to go out on a limb and say that everyone watching this right now or later has used schematics at some point. If you've used the Angular CLI, every time you run an ng generate command, you're using a schematic. When you generate a component, you're using schematics. And that's because the Angular team set up this great framework for us to use and said, this is how you're supposed to build a component, and this is how you're supposed to build a service. And here's the boilerplate to get you started with that. I can remember back early days of Angular, we didn't have that. We had hey, here's how you build a component. And so when you build a new one, we copy new files over, make sure, tweak the settings that we wanted to change, make sure everything was kind of right, adjust the module to make sure everything's wired together right. And it worked, but there are lots of things, that's a lot of things you have to get right, and a lot of things that you can get wrong just to put a new feature in place that's already been defined. So it wasn't the best way to go about building a new feature. When the CLI came out, we had these schematics, and instead of trying to copy over all the right files and get the wiring right, I could just say generate component, and that work is done for me. What a lot of people don't realize is Angular has provided us with the tools to take those same schematics and put them into our custom applications. And so if I have a feature to say, this is how this new feature needs to be set up, instead of the new developer copying over the files from the last one, they can run my ng generate command and get all the boilerplate set out there, and then start putting in their custom logic. Just a quick example, my last project, we had every time a new feature was put into place, I needed to create two new libraries. One library was responsible for communicating with the API, managing the client state. Another library was responsible for all of the UI components associated with that feature. And those two had to be connected. We were using NX, so we needed to set up the dependency graph so that they could depend on each other in the right way. We also set up a test application so you could test out this feature standalone from the rest of the app. These were a lot of pieces to get right. And so schematics really helped us in going a long way to getting developers on the right path. Now, as I move off the project, as other developers move off the project, those standards are encoded in the schematics. All right. So now we're going to go into the how of schematics. And this was a big hurdle. I feel like there's a big it's still not easy to get into working with schematics. The documentation's gotten a lot better, but it's really example-based documentation. I think the API docs are a little bit lacking. And when I first got in there, it's really intimidating. As I dig into the code of how the current schematics work and compare it to the docs, it's kind of an intimidating hurdle to get over. And so that's what I'm going to try to do here is remove some of that intimidation, show you it's not that hard to make your own schematics, and hopefully get you on the path to writing them. So I'm going to switch over, show the docs for a minute, because this is just the commands that we need to run to get set up. So the schematics are provided separately from the rest of Angular. If you want to work with schematics, you need to do a global install of the schematics CLI. Once that's installed, you have an easy command line, schematics blank, and then you give it the name of the schematic collection you want. This was the first point of confusion that I hit that I don't feel is very clear here. So the name that you're giving it here is both the name of the collection of schematics you're creating and the first schematic inside that collection. So when we think about collections, we think about at schematics / Angular, I believe is the name of the Angular built-in schematics. And then within that collection, we have individual schematics like component, directive, service, whatnot. This command kind of puts those two things and combines them into one. So when I ran this, I ran this with the name of the schematic I wanted to run, but it also named my collection the same thing. So I had to do a little renaming. We'll talk about that in a minute. Let me step back, and I've already created a repo with my new schematic in it. And the use case that I've created is a smart view pair of components. This is something that we teach a lot in our classes. And instead of having one component that's responsible for reaching out to the API or service layer, wherever it is, subscribing to the data, unwrapping that subscription, and then displaying it in this complex template, we sometimes split those apart. And we have a smart component that's responsible for communicating with the service, unwrapping the data from the observable, and then passing it to the view component. The view component has very little logic inside it, and it just receives some data, and then it can create that complex template because it's no longer communicating with observables or having to worry about data changing. It just receives the data as it needs to be displayed. And so I've created a schematic in order to create both of those components for us and then start to wire them up correctly. Switch over to my code. This is the result of running that schematics blank. So schematics blank means make me a blank schematic. And then I gave it a name of smart view. And over here, this is actually what it created. What it created for me was a top level folder called smart view. And then inside there, a source folder. And then inside there, another folder called smart view. Again, I wanted to remove some of this confusion. And so I renamed the top level folder to better represent the collection of schematics that I'm creating. So for right now, I just called it my schematics. There's a couple other things you need to change if you want to publish this collection, but for these purposes right now, this is going to remove some confusion. So I've got the my schematics collection here, and it's created the first smart view schematic. And inside here, the index.ts file is the important piece. This is the file that runs every time we execute our schematic. There's a few new concepts in here, and I think understanding the terminology used in this file goes a long way to understanding how schematics work and how we can start building our own schematics. And so the two big concepts I want to focus on are the tree and the rule. And so this tree, this is an object that is a virtual representation of our file system inside the project. It consists of two pieces. You've got a base, and that's what the file system actually looks like now. And then you have a staging area, which is where you're placing all of the changes that you'd like to make as you run the schematic. And so everything that we change is going to be done inside the staging area, nothing's actually committed to disk until the schematic completes. This is really nice because if you error out somewhere along the way, you don't have to worry about your file system being in a broken state. You also get access to the dry run flag. I use this all the time when I'm running standard schematics. If you do a dry run flag, it's going to show you what files it's going to create, what files it's going to change, but it's not going to actually change them just yet. And so I'll show that off when we start running the schematic. A rule is just a function that accepts a tree and then returns a new tree. So when we run this rule, we get in the tree that's either the initial state of our file system or the result of the last rule that we ran. And we're going to do some logic to modify the state of that tree, and then we're going to return it. So that's all we're doing. That's all a schematic is. And so this is our first schematic. It doesn't really do anything yet because we haven't put any logic in this function. We're going to start doing that in the next step. Schematic context has some more metadata about the schematic itself. We're not going to go into that for the scope of this talk. It's actually, honestly, it's not something I've ever used in the schematics that I've written. You can look into that if you ever get to where you need more context. All right, let me flip over to my repo. So I've got this repository. It's broken up into small steps. I've got this published to GitHub. I'll share the URL at the end of this talk. But the first thing that I wanted to do, oh, I'm sorry. Let me flip back. There's one thing I forgot to cover here. The other main file is this collection.json. And this is in the source, at the root level of source directory of my collection. This describes all of the schematics included inside this collection. So for each one, we're going to get a name of it. We can give it a description, and then the factory is the pointer to that rule function that I just showed in the index. So in my next step, I'm actually going to change the pointer for this factory, because these schematics are just TypeScript applications. There's nothing, the Angular CLI doesn't really do anything with this. If I look at the build scripts here, you can see it's just compiling this TypeScript file down to JavaScript and then running it. By default, when you create a new collection, it's not going to specify an output directory for your application. And so if you run a build right now, it's going to fill up your source directory with all of the output. So that was the first thing I actually did. Is I changed the output directory. So now on the second step, tsconfig, I just made this output to a dist directory. And because of that, I needed to change my factory to say, when we run this Smart View schematic, here, this is the location of the file that you need to run. So over here, I'll do just an npm run build. I like it because it's a one file. It's really quick. So you can see that it put my files in this dist directory. Now it's separate from my source. Okay, so we have the basics of how to make a schematic, what a schematic does. Let's start building our first schematic. So the first thing I want to do is I want to get an input from the user. I'm going to get the name of the component that needs to be built. So we'll switch to this commit. Now, I had to do a couple of things. This is one thing another thing I wish was built in and just came out of the box is this schema, because your schematics are always going to have a schema along with them. You always need some sort of input from the user. If you're not getting an input, there's no way to modify or customize this template for what you need it to do. So this schema.json describes the inputs that you're getting from the user. So under my properties, I gave it a name. This is the first variable that I want to get is a name. You can give it a type and description. And then there's this other piece of the API that I gave it, and this is a default. So this $default property means if when running this command, if you don't put in the -- name parameter, it's just going to grab it from the arguments and it's going to get that first argument that's passed in. So I'm going to go over here and do a run build again with this. And I actually set up a demo application that I can just use to run these schematics. And so I'm going to look at what the output of this schematic looks like. So it's a ng generate, or NGG as the shorthand, just like you'd run any other schematic. In this case, I need to give it the collection next. And in this case, we're going to give it the relative path to the collection where it stands. And so since my demo app and schematics are side by side, I'm going to go up a directory and then say my-schematics. When you're making these for real, you'll probably use npm symlinks. And so instead of giving a path, you'll actually give it the name of a package that you've linked to. Or you might end up publishing these and then it'll be a real npm package that you've installed. But because I don't have any symlinks set up, I'm just giving it the path to my collection and then a colon and the name of the schematic I'd like to run. So if I want to give it a name, I would then say -- name, and we'll call this hello world. If I run this, it looks out to my factory. We output the name. If I flip over to my index, that's all I'm doing right now is I'm outputting the name. So this options that's passed into my factory function are the options from the schema, whatever the user put in. And so I like to define an interface that matches what that schema looks like so that I can get some TypeScript help when I'm writing my function. So this, I made name a required property. So I made it required on this interface. And then when I get my tree, actually not doing anything with the tree, I'm just logging the options and returning the tree as it is. So because I set this up as a default, I can leave off that name flag and just say hello world. And it's going to give me the same thing. That's what the default flag did for me. And because of that required on line 12, if I don't put anything in, I actually get some error handling or some error reporting from the schematic itself. Okay. The other thing you have to do, because the schema JSON is not generated by the schematic, I had to update my collection to tell it about the schema. And so I added another property to the smart view component, defining where the schema file exists. All right, so now we're getting in a single input. Let's start building our components out. Now for this step, what we could do, schematics, I guess I didn't go with the top level of, what a schematic is defined to be. A schematic is just a way of is a template-based way of modifying your file system. And so when I generate a new component, if you've ever run that ng generate command, I guess we could do that here, ng gc for component. We'll call this one hello world. And I'm going to do a dry run so it doesn't actually change anything. But it's going to create 4 new files for me. And it's going to update my app module to add this to the list of declarations. And so when I'm creating my smart view component, that's exactly what I want to do. And I could do all this myself. I could create all the templates, put them in place. I could grab a reference to that module TS file, look for the declarations array and add my new component to it. But I don't like to reinvent the wheel. And so since all of that is done for me, I'm going to do what I do in most of my schematics. And I'm going to start by calling an existing schematic. I switch to my next commit. Calling an external schematic is pretty simple. We're bringing in this external schematic function from the Angular Dev Kit schematics. And notice that in this function, we're no longer defining the function, the rule function in place anymore. Now the thing returned by my smart view function is this I'm invoking this external schematic function, passing it a few parameters, and it's responsible for creating that new rule and returning it. I will say that most of the time when you're building a schematic, this is how it works. You're not defining these rule functions in line. You're calling out to another factory that generates a rule for you. And so here we're calling the external schematic rule. I pass it the name of the collection and the name of the schematic I want to invoke. I give it a few properties, just as if I was calling ng generate at schematic/angular :component myself. I would pass it these flags. So I'm passing that name on. I just gave it another property. I want it to have a SAS file. So if I build this schematic and go back and let's do a ngg with my schematic again, we'll call it hello world. -D is the same as dry run. And you see that the output from my schematic is exactly the same as the output from the built-in Angular schematic. So this is going to be our starting point. I would also recommend using these as much as you can. A few things that are not difficult to do in working with schematics: creating a new template and just modifying a few variables inside that template you've built, and then overriding or placing that new file into a system is not very difficult. Modifying a existing JSON file is not that difficult. Modifying an existing TypeScript file or modifying an existing HTML file, that's a little bit harder to do because you've got to take that existing file, transform it into some sort of object that you can then walk over and change the pieces that you need. It's a little bit harder to do. I try to avoid it where I can. And so since Angular's already provided me with this schematic that updates the app module itself, I'm going to take advantage of that. So that's what I'm going to do. As I'm building the Smart View component, I'm going to run two external schematics, one for the Smart component and then another one for the View component. And then I'm going to tweak some things in the templates and just overwrite a few of the files it created as needed. All right. So in order to do that, we need to chain multiple rules together. So the next step we're going to talk about is just how to chain rules. And this is a very small step. I tried to make these as incremental as possible with small changes. So when I'm calling multiple rules, chaining them together, the way to do that is just by importing this chain function from schematics and then passing an array of rules. And it's going to take those rules, run them in order, and return the result to the Smart View factory. So now if I build this again, oops. Flip back over. I'm creating one Smart component with the name that was passed in. I'm also creating a View component by appending -view. You can see that my dry run, it's going to create two components. It's going to update the app module to add them both in there. So now we're finally to basically the starting point I use for all of my schematics. I've got this chain function in there, and now I just need to keep adding rules in there to keep modifying the system until it gets to where I want it to be. So we look over at my list of commits and see there's only 2 left and think, oh, well, it's almost done. That was easy. The meat of the work is in these last 2 commits. And so in this commit, we're going to start adding some templates. So a template is just it's a template for a new file that I want to create. Normally a TS file or an HTML file. That's what we're going to be using here. There are some blocks in there where I need to inject some variables. I need to inject the name. I might have some other things that need to be customized for my schematic run. And so in this commit, all I've changed is index.ts, and I've also added this templates folder up at the top level. I like to keep all my templates off to the side. They can actually be reused by multiple schematics if we want to, or you can organize this however you'd like. I've created this templates directory at the top level. In here, I have a smart folder. This is my templates for the smart components. I also have a view folder with my templates for the view components. The reason I've really kept these separately is because they need to be placed in two different directories at the end. And I don't want to try to encode that directory structure inside my source files. Instead, I want to say, take everything from here in the smart component and put it in the smart component directory, and then separately take all of these components and put them in the view directory. We'll talk about the naming of components of templates in just a minute. So you see, now I'm bringing in a lot of functions from this schematics folder. Here's where I think the docs are a little bit lacking. They're kind of example-based documentation. It shows you, hey, if you want to create a schematic, here's an example how you would do it. Kind of what I'm going through here. But the API docs are a little bit lacking. And so I haven't found a source where all of these different available methods are just documented for you. I actually had to do a lot of digging into how current schematics work, or just looking in the node modules directory and seeing what's exported. So hopefully I can go through some of those and save you some of that trouble. So in order to start working with templates, we're going to look at lines 19 through 26 here. When you work with templates, you're working with an object called a source. So if I hover over this, you can see it's a source. And a source represents a list of files or a directory full of files on your file system. And so when I work with templates, I need to start with a source, and then I need to make changes to that source and then apply it to my tree. So this function, URL, and then you give it a path. URL actually takes a string that represents a path and turns that into a source. So this is how I transform all of the templates in here into a source that I can now begin operating on. You can think of apply kind of like a chain function, but for sources. And so I call apply and give it my initial source, and then an array of rules that I'd like to be applied to that source. And so the first thing I want to call on this is my apply templates function. Apply templates does a few things. So it's going to take all of the files in here. It's going to look for the files specifically that end in this .template extension. I actually don't know what happens if you throw files in there that don't have that extension. But these are what you need, are the .template extension. You pass it a configuration object, and it's going to make all of these key values available to use to be evaluated inside the template. And so in this case, the main things I need my template to be able to work with, I need the name that was passed in, because I need to know what the class name is going to be and what the selector names are going to be. And then I'm going to pass it these functions that are provided by the dev kit, these string functions. So classify is going to take a string and transform it to Pascal case. And so things like naming a class, I need that to be a certain case. Dasherize is going to do the same thing. It's going to turn it into kebab case. I'm going to use that in things like component selectors and file names. So I'm passing the functions along with the name, and it's going to apply those to the template. So let's take a look at my smart template now. All right, here's where the syntax can get a little, it looks a little messy when especially when you're working in an HTML template, because it looks so much like HTML. But this that I have selected right here is actually the way to work with variables inside your template. And so we've got this angle bracket %equals, and then the thing that I want to evaluate, and then a closing % angle bracket. And so it's going to take that dasherize function, run the name that I passed in through it, and put the output into place in the template, kind of like it works with an Angular binding. So what I'll end up here is app-hello-world-view. I guess I didn't talk about what I'm trying to accomplish with this template. Now that I have my two components created, I'd like to modify the template of my smart component to have a reference to my view component. And then I'm going to have a binding here that just passes a literal string down to it. We'll replace it when we actually implement this feature. But for now, I'm just going to bind the string hello world down into the component. Well, in order for that to work, I also need to modify the template of my view component. The TypeScript needs to be modified so that it has an input named message ready to receive this string. And then I'm also going to modify the template of that component. So instead of saying my component works, I'm going to replace that with a binding to this message. So we've got this set up. The apply templates is going to put the correct string in place of this syntax here. It's going to then strip the word, or it's going to strip the .template extension off of the file name. So what we're left with here, oh, it's going to do one more thing. The name of the component itself. This is another way to use that, use these properties here to change the name of the file that you're creating. And so we've got a double underscore on either side here. You can put this anywhere in the file name and it's going to evaluate it. And it's going to take name and it's going to run it through the dasherize function. So a little bit different syntax here, but it works the same way. We're going to end up with hello-world.component.html. Again, it strips .template off. And so that's what we're left with is the finished HTML file, but it's still sitting in this directory here. So the next thing I want to do is I want to move that file. And so here I'm giving it the path that I want to move it to relative to the root of my project where I ran the schematic. So I want this to go in source app and give it the name of the folder. We're going to do this, and what we're left with here is now the source that I can apply to my tree. So we're going to use that in my chain, pass it to a rule below. We're doing the same thing with the view template. If we look at the templates here, I'm actually not doing any kind of parsing inside this template. For the view, it doesn't matter what the name of the component is. I want to bind to the message. For my TypeScript file, because I'm completely replacing the file that's there now, I need to make sure I get all the pieces correct in here. So I need to make sure that the selector and the template URL and the style URLs all still tie back to the right file names. I also went ahead and threw a on push change detection in here. I think that's an important piece for using view components. And then I used the classify name below. This is the difference between dasherize and classify. I need this to be Pascal case for the name of the component. Then I go ahead and throw that input. So it should be ready to use now. So back on my input, or back in my chain function, now I'm chaining these rules together. So after I create the two schematics, now I call the merge with function, which is going to return a new rule. This is going to merge an input tree with a source that I've created. And so I just give it a reference to that source and then a strategy for the merge. Almost always, maybe always, when I've written these, I've used the overwrite strategy. I know that I've created a brand new template. There's an existing template of the same name, or there's an existing file of the same name, and I want to overwrite that file. So I use the overwrite strategy. So we create the new components, create our new templates, merge them in, and let's go see this in action now. So I build my new schematic. We're going to do a dry run here again. And we see that it's creating the same file, the same number of files, because I just overwrote the files. But if you look at some of these, you can see that Hello World component is a different number of bytes. The HTML and TypeScript, the bytes don't match again. So this is showing that, yeah, something did work. I'm doing something differently now. Let's go ahead and actually generate this and see them in action. So take the dry run flag off and create this new Hello World Smart View component inside my application. So now in my demo app, here I have a Hello World and a Hello World view. If I go look at the view component, I can see that it put all of the variable names in place where I expected them to be. And I guess big moment of truth. Let's go to the app component, give it a reference to my smart component. And we'll serve this and make sure it works. While this is getting up and running, let me just take a brief pause. I want to switch over and just talk about some of the upcoming events that we have. If you go to oasisdigital.com and just scroll down just past this picture, you can see our upcoming event schedule. We've constantly have new events coming up. You can see we've got an Angular bootcamp coming up next month, if that's something you're interested in. A Cypress webinar, I'd highly recommend that. Cypress is, I'm really interested in Cypress. I can't wait to see this webinar in action. But I would recommend that you take a look at this every now and then. We've always got new and interesting events on the horizon. All right, so my application should be running now. I'm gonna go back, do a refresh, and we see hello world. So that message was passed down from my smart component to the view component, and it's being displayed. We have a working schematic in action now. This is about, I mean, I almost stopped my talk here. This gets you about 80% of the way toward making a schematic. Now you understand the working with the file system, working with the existing schematics, modifying your templates to put them in. That's most of the work that you need to do. The next thing that I do want to show off is modifying a JSON file. This is something that comes up a lot, is in addition to the new templates we put in, there's some sort of configuration piece that needs to change, whether it's in the Angular JSON or the Cypress configuration. The use case I put in here is I wanted to add a custom prefix for my component. And so I want the user to be able to change the prefix added to the selector for this component. Oh, that would be great. I could do that all in the template. The problem comes in when I look at my tsconfig file, and I've got this linting rule that says, hey, components can only have the app selector. So if I create a component that has a different prefix on it, it's going to throw lint errors at me. So I'm going to modify my configuration. I'm going to modify my schematic so that I can also modify this lint configuration. So in my schema, I added a new property. I added the ability to pass in a flag or a prefix flag. I give it a minimum length of 2 and a maximum of 3. So there's different constraints you can put on these properties. I didn't make it required. And so in my index, first thing I do is I look at the prefix, or I look at the options. And if there's a prefix, we take it. If not, we'll just default to use app. Again, this is a pretty simplistic example. Really, you'd probably want to dig into your Angular configuration and find out what the default prefix is, or maybe you just don't pass prefix to these at all. There's a lot of different choices you can make here. But because I am using this prefix, I'm now passing it to my templates. I need to know what it is in the template because in my smart component, I need it here when I reference this view component. And in my view component, I need to append it now to the selector name. So that's another variable that I need to evaluate inside the templates. The next thing that I did, I passed it I also passed it along to the schematic. Prefix is an option that the component schematics use. And then I made this new function called update TSLint prefix rules, which I defined in another file here. So this file, this function is going to return that rule that we saw. Now I'm going to create my own custom rule. So I'm creating a function that takes a tree and returns a tree. First thing I did is I defined some of the interfaces. I know what a TSLint config looks like. I know it has a rules property. I know that rules property has a component selector property. And then inside that, what we're looking at is, sorry about that. What we've got is whether or not the flag is enabled, that it applies to elements, what prefix is allowed. This allows for a string or an array of strings, and then that we want it to be kebab case. So really all I'm checking for is this rule enabled, and what are the current prefixes that we allow for? All right, so the first thing I did, I've got this function that gets the TSLint config. So it passes in the tree. It looks to see, does this file exist in the tree? If not, we're going to throw a schematics exception. Then we're going to, if it does exist, we're going to try to read it and parse it as JSON. And if anything fails there, we're going to throw another schematics exception. Schematics exceptions are something that I like to throw. I try to put as much error handling in these as I can. Another thing they don't tell you about schematics is they love to fail silently. And so you'll make all these changes, you'll build it and run the schematic, and your change didn't work, but there's no output. Why not? Because you wrote the file and you didn't put an error in there. So I try to put in exceptions where I can. If anything goes wrong, give me some indication of what went wrong. So we get that configuration, read it in. I'm going to look for the component selector rules. I'm going to check that first property of the array to see if it's enabled, because if it's not enabled, I don't need to change anything. But if it is enabled, then I'm going to check that, that other index and see what are the current prefixes that are allowed. So, and again, everything I'm doing in here, this is not really related to schematics. It's just the logic of what I want to do. Or it's not related to the schematics API. I'm just doing some JavaScript logic in here. So is it already an array? If so, work with it. If not, wrap it in an array. Does my array currently include the prefix I'm working with? If it does, great, we're fine, move on. But if not, we're going to push that new prefix into the array, overwrite the config, and now we're going to reference the tree again. So remember that virtual file system we're going to call overwrite, give it the name of the file we want to overwrite, and I'm just going to re-stringify that entire config and push it back out there. And so we append this rule onto the end of the rest of my rules because I want it to happen. I guess it doesn't matter where this one happens, but this is going to happen after the components have been created, after my templates have been created. We're then going to modify the TSLint. So go back over here. We're going to do a run build. I'm going to go delete the old changes, my other component. So I can just get rid of all of the changes that I made inside the demo app because we want to make this from new. So now if I do a schematics hello world dry run, we're going to look. Oh, it didn't change anything. Didn't throw an error either. I actually know why this happened because this happened when I when I walked through this the first time. I didn't make prefix a required property. So everything's fine here. It didn't require prefix, so it didn't change the prefix and it didn't update my TSLint. But if I add prefix and I'll change it to hi. So we have a hi hello world selector now. Now you can see that it wants to update the TSLint JSON. Let's go ahead and actually make that change. And now if I go open up my TSLint JSON again, we see that the component selector has been modified and now it will allow for app or hi as a selector. In addition, my component now has hi as the prefix for the selector. All right. There's a lot of information. I think, again, if the last step covered 80% of where you need to go, I think this covers 90% of where you need to go to start building your own schematics. Hopefully this was helpful. I want to thank everybody for attending, for watching this video. Here's the GitHub where I've published this repo. So it's under my username, John R. Baur. There's an Angular schematics demo. Thank you. So I'll take any questions you might have.
Thank you, John.
So you mentioned the poor API documentation. Is there any API documentation? Because I wasn't even aware there was any documentation for schematics until about a week ago.
Yeah, there is documentation, but I haven't found, there's not an API documentation that you would expect. It's all just about, here's an example of how to create this. And actually, as I was, I was referencing the docs again because it's been a while since I've written a schematic. So as I was building this example, I was referencing and thinking, well, how do I do this? How did they get away with not doing this step? And I don't remember what it was. And then I looked and I'm like, oh, well, they made their example follow the edge case where you don't need to change this property over here. So those are the types of things that you can run into.
Yeah, we do a lot with the schematics, and they are powerful, but my gosh, the lack of documentation. And if you try to do something complicated like extend the new schematic, they can be a pain to maintain.
They really can. And that's why I don't know that it's the best solution. It's the best solution I've found, that I try to create new templates and overwrite existing files with new files, because I found that's just the easiest way to do it if you can make that work for you.
I think I'd agree with that.
In some cases you can't. If you're creating something where you need to modify an array inside your Angular module, then you've got to do that thing where you open up a file, get the nodes out of the TypeScript, and it's not fun.
No, it's definitely not. I easily spend twice as long on some of our schematics than we ever save in them. But it's nice and impressive to be able to roll up to a group and go snap new and hey, there's a project with everything you need. But my gosh, it doesn't save us any time.
The other thing that you really need to be aware of, because it bit me, especially if you build your schematics early on in your project, is as you make changes to how that template should look like. I go in and I change the library files. I say, oh, I need to always import this. And I change it in all the existing places, but then forget to update the schematic to do it as well. And so I don't have a good answer for how to remember to do that. But it's something to keep an eye on as you make changes to the application. Think, is this something that needs to be changed in my schematic as well?
Yeah. So I have a question
definitely
related to that. It's like, do folks use this enough or too much, or somewhere in between? What do you see out there in the wild for adoption of this?
I don't know. If you're asking me, I'd say probably not too much, because I think most people don't use it. But I don't know if it's used. I don't know if it's used not enough or enough. I hadn't seen anyone use it on a project until I started using it, until I just started talking with a new client, and they sent me over this very complex schematic that they're using to generate new small applications. So I know it's being used. I don't know how much.
Now, so how crazy, you said this is like 90% of the way there to like what you'd need. Like, how crazy can you get with this? Like, what are some examples of some more extreme things that you've seen done with these?
I'm trying to think back. I mean, I wouldn't even call it crazy. It's just like I mentioned before, if you're opening an existing TypeScript or HTML file and you need to search to see if a line exists and put something inside that line or after that line, the code to get there, it's not fun to write. It's not fun to read. That's where I think that other 10% is, though, is if you need to go in and modify some things, that's where it starts to get a little crazy. And again, the documentation, I don't believe there's an example of that in their docs. And so I had to go in and read the source code for, the generation of a component and see how they started modifying files. Try to follow that and try to use TypeScript helps a lot. I will say that, because if you're just reading the JavaScript, you're just guessing. At least most of the objects that they're working with are strongly typed. And so you can say, all right, they've got this object. That's how they got a reference to the file. I can kind of read through that, the definition of that object, and start to get to what I need to use out of it.
So other than, I guess, reading the source code and looking through the limited docs, are there any good places to go to learn more about schematics?
That's a good question. I can't think of any offhand. I know I don't even know where the blogs were. I know I ran across a few blogs that really helped me. I should have had those handy, and I don't right now. Yeah, but other than that, there's no standard, this is the place to go to look at schematics. If you're on the docs, this page on authoring schematics and schematics for libraries are helpful for the pieces they cover. They can be very helpful. I would say that the pieces that are documented, although they're not documented like a traditional API, the examples are documented pretty well, and they help you understand what's going on. So I would look at those.
All right, thanks. Other than the ones that come from Angular, are there any good just existing ones out there to look at, other than, I guess, the one that you just put on GitHub?
Narwhal. So actually that's where I had to go back and reference the docs as I was writing my schematics. I was doing this balancing act where I wanted to talk about schematics, and I didn't want to assume that you're already using NX, because not everyone is. But NX uses their own schematics platform, which is a little bit different. I don't know that their docs are any better either. It's very similar to this. Most of it translates over, because most of the time you're still calling out to, where are we at? You're still calling out to these functions. NX provides a few more things. I don't remember what they are. The big thing was you can do schematics inside a workspace. And so that's what made sense for me, is I don't need to publish this to the world. I need it to exist inside my workspace. And then I don't have to worry about making that. I don't need to worry about the relative path to where it exists or making symlinks. I just say call the workspace schematic and then give it the name of the schematic, and it just works. So there's a little extra layer there.
Any more questions?
Throw that up again in case you needed the URL.
Okay. Well, thanks again, John. Appreciate you coming and talking.
Thanks.
And we will see everyone next month. In the meantime, you're welcome to stick around and hang out and chat for a while.